in this chapter, in this recently that we learned how to solve the system of equations. And I heard so many complaints about that because it's so tedious and takes a lot of paper. Today I'm going to introduce something to you, and I guarantee that you're going to love it. You're going to love it. First of all, we talk about the determinants. Determinants. And then later, I'm going to introduce a very famous person, Cramer. You're going to love Mr. Cramer for sure, okay, at the end. Cramer's rule. So we're going to use that to solve the system of equations. Okay. So first of all, how do you find a discriminant of a 2 by 2 matrix? In order to find the determinant, I'm going to teach you how to find the determinant of a 2 by 2 and a 3 by 3 matrix. All right. Now there is a way to show that the determinant of a matrix is this. You write, see those are 4 numbers, okay? So you write them, instead of writing them in the bracket, you put like a bar. Looks like absolute value, isn't it? But it's not. It's called a determinant. So if you see this, that's a determinant. Okay, I tell you, how do you find a determinant? Determinant is actually one value for this matrix. What you need to do is you're going to use this one times this one, okay? And then later, you're going to use this one times this one. So you're going to use, let me call this as A1, okay. A1, and here I call this as B1, here's a B2, and this is B1 and A2. Okay. So the determinant is this, that equals A1 times B2, then minus A2 times B1. Hey, what do you think? The easy way to remember that is always start from the top left. So you go this, you multiply, you minus that product. Okay, so let's try a couple of questions, then you're going to see how do we do that. It's very easy. Okay, so I ask you to find the determinant of this. 10, 9, 6, 5. Can you do it? You're going to say yes. The determinant looks this. 10, 9, 6, 5. Once you put them in this bar, I know you're going to give a single value at the end. You're not going to write here equal, okay, because this is a matrix. Matrix is not a single value. It's just the list of the numbers. Put them in rows and columns. So you're going to do starting from the top left and then drag down. So 10 by 5. So that will be 10 times 5 minus 6 times 9. 6 times 9. Okay, so that will be 50 minus 54. So my final answer is negative 4. That's my answer. What do you think? In order to get the determinant, then you have to put the matrix number, list them, but put a bar on both sides. Then you do the cross product minus another product. One more. Find the determinant of this. 12, 10, 6, 5. Hey, easy. 12, 10, 6, 5. That equal, because that's a vertical bar, so I can just go ahead and do 12 times 5 minus 6 times 10. It doesn't matter you do 10 times 6 or 6 times 10. So I like to do this way. This is much easier. So that will be 60 minus 60. That is 0. Okay, is that interesting? Yes. Okay, so I tell you this. After you learn this, this is so important. I give you an equation. The equation looks like a1x plus b1y equals c1. and a2x plus b2y equals c2. And I will ask you to do, can you do this? a1, b1, a2, b2. I call this as a D determinant because I'm looking for the determinant of the matrix of just the coefficients. And then watch. The next one, I am going to use the letter C1 and the C2 to replace A1, A2. Okay, I'm going to use the C1, C2 to replace A1, A2. I got a C1, C2, and keep B1, B2. Because you're using the constant term or the C term, you use that to replace the A. Replace the A. And then we will call this as a dx. So that means you're using the number to replace the coefficient of x. Okay? And of course, the other one is dy. You know what is dy, right? So we're going to use this C1, C2 to replace. So I have a A1, A2 stays, but I use C1, C2, C2 instead of B1, B2, and I call this as dy. It's not bad at all, but the beautiful thing comes. Mr. Cramer come in and he said, okay, x will be the value of your dx over d, and y will be dy over d. That's nice. That's beautiful. Okay? So let me show you how to do that, and you're gonna love Mr. Cramer. I tell you that. I guarantee it. I give you this 5x plus 4y equals 12. 3x minus 6y equals 24. This is a system of linear equations in two variables. I ask you to use Cramer's rule to solve it. Okay, so let's find a d first. D is the determinant of just the coefficients. So that is a 5 and a 4. Okay, and then here's a 3 and a negative 6. Okay, do you know how to do that? Yes. So 5 times a negative 6 minus 3 times 4. So that's a negative 30 minus 12. The answer is a negative 42. So far so good? Yes. And then dx. dx means I'm going to use this 12 and 24 to replace the x coefficient. So that's 12, 24, and I keep the y's coefficient, which is here. Okay? You see what I'm doing here? All right. Now, that is 12 times negative 6. I know it's a negative 72. And then minus 24 times 4. So that's a negative 72 minus 96. It's a big number. It's a negative 168. So that's dx. I'm going to work on dy. dy will be, I will use the 12 and the 24 to replace this 4 and the negative 6, but I keep the 5 and 3. Okay? And here it's going to be 12 and 24. So that is a 5, because this is a vertical line, so I can calculate it. So 5 times 24 minus 3 times 12. So that's 120 minus 36. So that answer is 84. So I got a d, I got a dx, I got dy. Mr. Cramer says x equals dx over d, which is negative 168 over negative 42. That's 4. Okay. And then y equals dy over d, which is 84 divided by negative 42. My answer is negative 2. So my answer is 4, negative 2. Done. Isn't it much easier, much faster? Because I love this. I love this. This is much easier. A lot of students, after they learn Cramer's rule, I ask them, well, what method do you want to use? You want to use the one we learned in early chapter, perform use the substitution method or elimination method, you're going to reduce the number of the variables, go through all the steps. Or you want to use the matrix method. A lot of people say, no. But when I ask them, do you like to use the Cramer's rule? And everybody said, yes. So this is about a 2 by 2, and we learn how to calculate the determinant of a 2 by 2 matrix. So are you ready for a complicated one, which is a 3 by 3? So instead of writing A1, A2, B3, that kind of thing, or if you want, I can still write it. Okay, so A1, okay, A2, A3, B1, B2. Don't be scared. Those are just numbers, but I will tell you that. Okay, this is a C1, C2, C3. How do you calculate the determinant of this 3 by 3 from a 3 by 3 matrix? Okay, I tell you this. I always prefer the students do this. Underline here, plus underline, and then minus, underline, minus, underline, minus, underline. Of course, if you like to put a little box, that is okay. And I told them that it's like you have to fill in this box or put the number in the box. It's like the choo-choo train, isn't it? All right, now. The product of A1, B2, C3 goes to the first box. This way, right? From top left and down. And then this A2, B3, but not done yet. I have to include a C1 because I need 3 numbers to multiply, and that goes to here. You see? And of course, this one, the last 2, and this, because you have to make 3 numbers multiply, and that goes to here. Yeah, I just put here. Okay, so that's the product of these 3 numbers go here, the product of these 3 numbers go here, and the product of these 3 numbers go here. So you're going to have 3 numbers. That's the top, that's the first part of your choo-choo train. And then the second part is going to be minus, minus, minus. But minus is very confusing. So I like to put things in the box. And then the minus, what would be the 3 numbers you put in the box? Tell you this, it's going to be the product of this guy that goes to this box. And of course, you know what I'm going to do, right? So the product of this with this, that goes to the second box. The other one, I have this, and I need to multiply by that, and that goes to my last box. What do you think? It's hard. All right. There's another way to do it. I'm not going to go to the detail about that, and there's a way to do it. There's always some way to do it. And someone says you're going to expand by a certain row or certain column. I don't want to go there. But I think this, I always like this choo-choo train method because it works. Okay, so question. Can you evaluate the determinant of this matrix? 2, 1, 7, -5, 6, 0, -4, 3, 1. Did you notice that I use a bracket, which means that's a matrix, right? That's a matrix. So I need to find the determinant, which is a 2, 1, 7, -5, 6, 0, -4, 3, 1. That equals 3 numbers add up, and then minus another 3 number. I like this method a lot. All right, now the first number is always go from here and then go this way, right? So that's 2 times 6 times 1. What is 2 times 6 times 1? 12. Okay, And then you can just do -5 times 3 and times 7. You're not going to go to here because this 1, 2, 3, you need 3 numbers. So -5 times 3, that's a -15, times 7 is -105. Now, you see the benefit I put in the box instead of just keep writing, because in the box I keep the sign, so it gives me less chance to make mistake. Okay, the last one. -4 will times these two numbers, so -4 times 0. Okay, when you see 0, you're happy, you just get a 0. That's the 3 positive numbers. And then we're going to work with the negative part. And here I have the negative outside, so I don't need to worry about the sign right now. So I do 7 times 6 times -4. What is 7 times 6 times -4? 7 times 6, which is 42, times 4, so that would be 100, that would be -168. Even here's a minus outside, but inside it's still negative. So that's why a lot of people get confused about the sign, and I prefer this method so you won't make a mistake. Okay, after you do this, you can either do this way or you can either do this way. The order doesn't really matter as long as the direction is right. So let's do this. 1 times -5 and 1, so that's -5. Okay, and the other one, that's just 0. All right, now once you have this, then it's much easier. So you're going to have 12 minus 105 plus 0, don't worry. And here is a plus 168 and a plus 5. So you only need to find what is the final answer. What do you think? Looks good. Okay. So let me see. 94. So I get it. 80. Because that is -105 plus 5 is -100. And here will be 68 plus that. So my answer is 80. That's my final answer. That's the determinant of this 3x3 matrix. Okay. There's another way. Let me just introduce it just in case, okay? So if you have like A1, again, A2, A3, B1, B2, B3, and C1, C2, C3. There's another way to do that is this, is you can expand by, let's see, we're going to expand this by the first column. So I'm going to have A1 multiplied by what? Multiplied by A1, you cross out the row and the column that A1 stays. So you have a B2, C2, B3, C3. Okay. And then the next term will be A2, and then you cross out the row and the column that A2 states. So you have B1, C1, B3, C3. For this 2 by 2, you know how to do that, right? And then the last one is A3, and then cross out the row and the column that A3 states. You get a B1, C1, B2, C2. Here's a multiplication, okay? And then the next thing is the sign. Okay, when you expand from here, it's a positive. So here's the tricky part. The positive and negative, positive, negative, positive, positive, and negative, negative, positive. So there's another thing you have to remember, which means if you expand from this A1, so that's going to be positive, and then the next one is negative, and here's a positive. Okay, so that's how you do it. So that's why usually I don't really like this method a lot, because I think the other one is much easier. However, if you like, you can continue, because you will, if you like to expand by the second row, if you want to expand by the second row, so that will be A2. So you leave the sign, do the sign later. So if you want to expand by this, so that's going to be A2. You cross out the row and the column that A2 stays. That will be B1, C1, B3, C3. And then A2. The next one is B2. So cross out the row and column that B2 stays is going to be A1, C1, and A3, C3. And the last one is a C3, C2, and you cross out that, you have A1, B1, A3, B3. Here's 2. Then you're going to determine the sign, and you're starting from A2. See, that's negative, so it should be negative, positive, negative. So that's another way to do it. Okay. Again, once you reduce that from 3 by 3 to 2 by 2, in order to calculate that, you just use B2 times C3 minus B3 times C2, and then multiply by A1. That's your first number. So either way, okay, I'm not going to go to the detail. I think you already get the idea. All right, now I really would like to go to how to use it, how to use Mr. Cramer's rule. Let me give you a equation, system of equation. 3x minus 2y plus z equals 16. 2x plus 3y minus z equals negative 9. And the last one, x plus 4y plus 3z equals 2. I ask you to use Cramer's rule to find the solution. Okay, first of all, let's find d. D is just the coefficient. It has nothing to do with those numbers. So that's going to be 3 minus 2, positive 1, 2, 3, negative 1, 1, 4, 3. Okay. Now you see why I like to use this method. Okay. Minus. Okay. Now the first box we're putting is the product of this, which is 27. Okay. And then after that I do 2, 4, 1, which is 8. And then 1, negative 1, negative 2, which is positive 2. Okay, you see what I'm doing? All right, now the other side. 1, 3, 1, that's a 3. Okay, and then negative 2 and 2 times that, which is negative 4, times that is negative 12. See, I don't need to worry about this negative. Don't worry about the minus. I do that later. But when I work on the product, it's much easier, right? And then one more. So after I do that, I have to do negative 1, 4, and 3. So it's another negative 12. So basically, you write a 27 plus 8 plus 2 minus 3 plus 12 plus 12. Okay? So if you want to use a calculator, you can do it. If not, then you're going to say this is 27 plus 8, 35. 35 plus 2, 37. Minus 3, 34. 34 plus 12 is a 46. And 46 plus 12 is a 58. Okay, so that's your answer. It's not bad, right? Okay, I'm going to continue. I'm going to get a dx. Remember, dx is using the number after the equal sign and replace that replace the x coefficient. So we don't need to worry about that. I put a 16, negative 9, and a 2, and a negative 2, and a 3, 4, 1, negative 1, and a 3. Okay. So again, in your scratch paper or somewhere, you can just do this. Draw a true. Okay, so we got a 16 times 3 times 3, so which is 144. All right, and then of course, if you like, you can use calculator. And here's a negative 9 times 4 times 1, so that's a negative 36. Okay, so after you do that, you need to do 2. And with this, so that is a 4. Okay. The other way, I go from the top right. So 1, 2, 3, that's a 6. Okay. And then I do this. Negative 1 times 4 times 16. This is negative 64. Okay. that. And then I'm going to do 3 times 9 times negative 2 becomes a positive 54. Then I have 144 minus 36 plus 4 minus 6 plus 64, you see, minus negative, and then minus 54. Okay, so if you like, you can just use a calculator, or if you like to do this by heart, then 64 minus 54, so this part is a 10, and here 4 minus 6 is negative 2, so this is 8, and this 8, 144 plus 8 is 152, right? Yeah, and 152 minus 36, 152 minus 36 is 116. That is your dx. Same thing, you're going to use this 16, negative 9, and 2 to replace this, and then to find the choo-choo train, okay, and to find the determinant, you get a dy, and the same thing, you're going to use this to replace the 1, negative 2, and 3 in the last column, and to get the dz. And once you get that, your x will be dx over d, your y will be dy over d, and your z will be dz over d, dz over d. So that is how beautiful this Cramer's rule is. So let me go ahead and finish it. Okay, I'm going to finish that. I get a dy. That will be, I keep the first column, 3, 2, 1, and I use the constant number 16, negative 9, 2, and then I keep the last one. 1, 3. Okay, so if you like, I always prefer to do this. I strongly suggest you to do this because they really give you less chance to make mistake. So 3 times 9 times 3, that's negative 81. Okay, and then 2 times 2 times 1, which is 4. And then 1 times negative 1 times 16 is negative 16. Done. This way. 1, negative 9, 1, this is negative 9. Okay, and the negative 1, 2, 3, that's a negative 6. Okay, 16 by 2 by 3. Okay, so 16 times 2 times 3. So that's 96. All right, so that is negative 81 plus 4 minus 16 plus 9 plus 6 minus 96. This is my dy. Okay, my dy, if I look at that, see positive 6 and negative 96, this is negative 90. And a negative 90, and so I get this 10, so I get a negative 100. So I leave that. So 4, and this is a 3, that's a 7. So it's positive 7. So I'm doing things in my head. So negative 81 and 7, so I get that's 74. So that answer is negative 174. Okay. And then dz. dz is, I'm going to keep the first 2 column and then replace the constant in the, replace the last one. So I have a 3, 2, 1, negative 2, 3, 4, and then I have the 16, negative 9, 2. That is, I need to find the product, 3 positive and 3 negative. Okay, so 3, 3, 2, 18. Okay. 2, 4, 16, 128. Okay, that's 2, 4, 16, right? Yeah. And then 1, negative 2, negative 9 is positive 18. Backwards. 16 times 3, that's a 48. Okay. And then negative 2, 2, 2, negative 8. Oh, sorry, here should be minus. Why I put positive there? All right. And the other one, 3, 4, 9. So that will be 108. Negative. All right. So that is 18 plus 128, 18 plus 128 plus another 18 minus 48 plus 8 plus 108. So many 8s, and there's only one negative. Okay, so that equals, if you do this, is 18, 18, that's a 36, and plus that is 156, 166. 166 minus 40 is 126. So the answer is 232. I think I'm right. Okay. Whew. Okay, so I get a D. Let me just write that. D, I get a 58. Okay, I get a dx, which is 116. I get a dy, which is negative 174. And I get a dz 232. Mr. Cramer says x equals dx over d, which is 116 over 58 is 2. Y is dy over d, that is negative 174 over 58 is negative 3. And the z equals dz over d, so 232 over 58, answer is 4. What do you think? You got the answer. 2, negative 3, 4. That's how much my other students love Mr. Cramer. I don't know. I don't know how about you, but this is how you do it. Okay, so once you have this equation, you figure out a d, you figure out a dx, a dy, dz, and then Mr. Cramer just came in and said, okay, I tell you what is x, y, z. Just do simple division. But when you work on the 3 by 3 matrix, you want to find the determinant of a 3 by 3 matrix, I strongly suggest this train method. Okay, so have fun.